Question number 40. Which of the following statements is or are correct regarding some industrial processes? Statement A. The first two steps involved in the manufacture of sodium carbonate by Solvay process are endothermic. That is actually wrong. These are the 5 steps. There are 5 steps. Some say 4 steps. 5 steps of sodium carbonate manufacture. It's a Solvay process. It is also called ammonia soda method. The 5 steps are: first one, ammonification. Here we add ammonia, or we dissolve ammonia gas in a brine solution. Let's say, so it's dissolved in H2O to form ammonium hydroxide. Now this is an exothermic process because dissolution of gases in water are exothermic. The second step is carbonation. Now the carbonation means dissolution of carbon dioxide in the brine solution. It is also a dissolution of a gas in a water solution. This will produce carbonic acid. So this is also an exothermic process. Just remind the 3 other steps. The third one, separation of sodium bicarbonate. Fourth one is roasting of sodium bicarbonate. Here we get sodium carbonate. Roasting of sodium bicarbonate to obtain sodium carbonate. The last step is recycling the byproducts. Some say that the fifth one is not a real step in the Solvay process. Therefore, they say the Solvay process has only 4 steps, but we can assume that it has 5 steps. The recycling of byproducts will look like this: calcium hydroxide or calcium oxide with ammonium chloride gives calcium chloride and ammonia and water. So I'm not going into more details because it will take a lot of time. The video will be a very long one. Therefore, I'll stop right here. We just only need the first 2 steps, and these 2 steps involve dissolution of gases in aqueous solutions. So those are exothermic processes. Therefore, A statement is incorrect. The statement B: the presence of magnesium, calcium and sulfate ions in brine hinders the production of NaOH using the membrane cell method. This is kind of a true statement. Some can say this is incorrect because the brine solution that we must use in a membrane cell method should be 100% pure, because otherwise the same thing can happen. Now a brine solution is a concentrated solution of salts, highly concentrated salt solutions are called brine solutions. So it can be sodium chloride, calcium chloride, magnesium chloride likewise. So brine solution, the most common natural brine solution is the seawater. If we directly use seawater, it contains lots of magnesium and calcium and also sulfate, and these will get precipitated and in the NaOH membrane here in the NaOH membrane cell method. Therefore, it can destroy the membrane of the membrane cell. So B statement can be taken as a correct statement and also as well as an incorrect statement, because for the membrane cell we must use a pure brine solution and a pure sodium chloride solution. So some can argue that the brine solution we use in the membrane cell doesn't contain these ions, but the definition of a brine solution doesn't help that. Therefore, it is better to take this statement as a correct statement. Statement C. The first step involved in the manufacture of nitric acid by Oswald method is the oxidation of ammonia gas using oxygen in air in the presence of a catalyst to give NO2 gas. This is wrong. It doesn't give NO2 gas, it gives NO gas. Let me show you the reaction. 4 ammonia gas reacts with 5 oxygen gas to give 4NO nitric oxide, 4NO gas and 6H2O gas. This is the first step. This is a highly exothermic reaction and it requires 10% rhodium containing platinum catalyst, 10% containing platinum catalyst, about 900 degrees Celsius and 1 atm pressure. Now, these are the conditions for the Oswald process. This is the first step, step number 1. Step number 2 is actually reacting NO gas with oxygen to give NO2 gas. This is the second step. It is also a highly exothermic reaction. Now the first step, we mix ammonia and oxygen in the volume ratio of 1:10 or 1:9, because we use atmospheric oxygen here. Now since this reaction is highly exothermic, it generates a lot of heat. The temperature of the resulting mixture will be around 900 to 1225 degrees Celsius. So high temperatures demotivate the second step reaction. Therefore, we have to cool down this reaction mixture, this product mixture, up to 150 degrees Celsius, so that we can get most of the NO2 from this reaction. Therefore, this is the second step. The second step produces NO2, not the first step. Therefore, the statement C is incorrect. The statement D. High temperature and low pressure conditions are employed in the manufacture of ammonia gas using Haber-Bosch process. That is also incorrect. It is not high temperature and low pressure, it's high temperature and high pressure. The temperature is kind of an optimum value. It's a moderate temperature, let's say, but 450 degrees is kind of a high temperature. It's definitely not a low pressure. It's a very high pressure. So let me show you the ammonia production process. N2 gas reacts with H2 gas. It's a reversible reaction to produce ammonia gas. Now here we use iron catalyst and 450 degrees Celsius temperature, 250 atm pressure. Now this is really a high temperature. This is an exothermic reaction. Therefore, low temperatures are favored by this reaction, but we cannot decrease the temperature as the rate of the reaction gets decreased. Therefore, the efficiency will decrease. So it will take a lot of time to give a small amount of products. Therefore, to increase the rate of the reaction, we have to increase the temperature, but we cannot increase the temperature up to 1000 degrees Celsius, because ammonia decomposition will be more faster than the production of ammonia at 1000 degrees Celsius. So the rate will be higher, but the amount of product that is being formed will be almost zero. Therefore, we have to come to an optimum temperature, that is the 450 degrees Celsius. Now the pressure increments will help the equilibrium to shift towards the ammonia side. Therefore, higher pressures are used here, but even higher pressures than 250 atm will be more expensive. Therefore, the optimum pressure will be 250 atm for the Haber-Bosch process. Alright, so our answer will be statement B. That means the answer is 5. Let's move on to the next question.